Hello everyone, welcome to the new episode of the series 3D Archaeologist. Last time we got to know different passive and active 3D digitalization methods and their characteristic elements. Today I will focus on the last one from the active method groups, scanning with structural light technology. Besides presenting its main features, I will also show the potential of the software based on devices from the Polish company Smartech 3D, which is a producer of scanners and software with over 20 years of experience. The company uses technology invented by a group of scientists from the Institute of Technology in Warsaw, led by Professor Małgorzata Kujawińska. Scanning with structural light technology enables 3D geometry sampling even on the whole surface and place every measured point in the coordinate system. Every measured point has known determined measurement uncertainty, which means we know what is a possible mistake of the placement of every point. For scanning with structural light, such a mistake can reach 0.005 mm. As a result of the scanning process, we will achieve a cloud of points based on which the 3D model is generated. The line of Smartech 3D scanners dedicated to archaeology can register every point with the information about the color saved in the RGB scale. So the created cloud of points has not only determined coordinates, but also is colored, which can be useful in further research. The use of appropriate software allows to automatically transform the cloud of points to the metric 3D model as a triangle mesh, reflecting the color and the texture of the original object. As a result of placing the model in the coordinate system, achieved artifact representation can be measured in every plane. 3D models are an exact copy of a scanned object, so data from the scanning process can be used for digitalization and the archiving of the collection. The achievable resolution of an image is the biggest of all methods that I described and can reach 0.01 mm. Accuracy is up to 0.005 mm. Scientists can impact the accuracy by changing the measuring field, so the volume we are able to measure with a single scan. Increasing the measuring fields leads to decreasing the accuracy of achieved model. It can be useful, for example, when on a certain stage of a research we don't need the data on an archival level, but we want a smaller size of a data file. The flow of scanning with structural light technology is a necessity to provide a constant light supply. Measuring on the sunlight is possible, but hard to perform and relatively less precise. Also, it is recommended to use that method of 3D scanning for documentation of objects with dimensions smaller than 2 meters. Measuring bigger artifacts is possible, but more time-consuming. The software dedicated to 3D scanning with structural light in the Smartech 3D scanners is very simple and intuitive. The measurement process is touchless, which increases the safety of the delicate artifact, and the process leads to documentation that is detailed, precise, and free of most errors that can be developed during traditional manual archaeological documentation. All that is needed is to place the artifact on the rotary table, calibrate it with the scanner, and start the scanning process, and the device will perform the measurement of the whole surface without any interference. A single scan can take less than 1 minute, so depending on the size of an object and the software settings, we can achieve a finished metrical model with a color and texture reproduction in several minutes, while drawing and photographing complicated artifacts can take even few hours. If the object is too big to fit into the measuring field, or we don't have an access to the rotary stage, we can make measurements using positioning markers and scanning place by place. Markers are automatically connected by the software, resulting in a cohesive 3D model of an object. Scanning with structural light technology closes the group of the active methods, which will be described in the series. To sum up, 3D documentation can be divided into active and passive method. Passive methods don't project any kind of light on the artifact. In this group, there are photogrammetry, which generates a 3D model based on the photos, and characteristic points on the image are placed in the coordinate system, and structure from motion method, which creates a 3D model based on photos without placing it in the relation with a coordinate system. The second group of 3D digitalization methods is active, where data collecting is based on the registration of the projected beam. As this group, we can classify laser triangulation, which collects data with the use of the laser beam, time of flight, that register the time of the laser beam flight and because of the low accuracy is recommended for documentation of the bigger objects, and scanning with the structural light, which we learn about today, the most accurate from all of the methods, that is based on the projection of the fringes and is perfect for archaeological documentation. After scanning, the software provides a model we can watch up close. We can analyze details, even such small as fingerprints on the pottery or microfractures. We can take many measurements, we can take many pictures from different angles, we can generate a report or a virtual cross-section. On the next episode, I will show you step by step how the scanning with the structural light technology looks like and what is the potential of SmartTech 3D Measure software. See you then.